Okay, science time. Today we're talking about let's say evidence. That's a good word to start with for a science lesson. Evidence of changes in life. On what planet is there life?
This one.
Yeah, the only planet that we have evidence that there is life, to my knowledge. Yeah, dated December 6th, 2023, is Earth. That's, I remember there being something about, there's been a couple of very, not maybe sketchy, their evidence is real, but it's a pretty big leap to say that that does mean life. There's some, if I remember correctly, there's some evidence of maybe long chain amino acids that were found on Mars that might be the remains of single-celled organisms. There are amino acids that we still continue to find in asteroids and things like that. Some space rocks have just amino acids as part of them. Remember, that's one of the prevailing hypotheses as to the physical beginning of life on Earth, is that it might have come from asteroids and made like a primordial soup. That's one of the prevailing hypotheses, and that's obviously simplified for your consumption. But there's also something about like some gas that we normally only find produced by life found on some exoplanet, so maybe there's life there, but there's also there's some hypotheses as to how that might form in inorganic ways. But generally, the only planet for which we have hard evidence that there is or ever was life is this one. Life might just be a fluke. It's not just a fluke. They're important.
This is awesome.
But it might be singular. It might be only in this location. We just don't know. The objective: model changes in life throughout Earth's history. Model changes in life. The last objective was use fossil evidence to describe Earth's history. Now we are going to use probably that same evidence, but evidence in general, to model changes. What is it? Model changes in life throughout Earth's history. In life throughout Earth's history. Remember, we talked last time about the history of Earth, and we talked about how we obviously cannot go to Earth's history in so much as the word go would apply. We can't go, oops, sorry microphone, sorry T, sorry keyboard. We can't go back in time. You remember that? Remember how you have all those regrets and you would go back in time and you would change them and then that would mess everything up for everyone else? We can't go back in time. So you have to use evidence of Earth's past in order to learn about Earth's history. What kinds of evidence are there, specifically for those of life? Let's think of some. What are some good evidence for?
Fossils.
Yeah, fossils. That's the best one. That's why, as we were saying, well, I made a really fancy F there. Fossils. As I was saying to Joe before we started the video, not about the Black Eyed Peas song, but before that, that we are going to continue to use fossils in our learning, but our learning is not about fossils themselves. For the next couple of units, we'll be learning about things that pertain to fossils, for which fossils are good evidence, but that we aren't per se learning about fossils. What else? What else can we use as evidence for life on Earth's history? Yeah, current life. And really, these are the two prongs of the pitchfork of the mob of let's learn about how life used to be. The two prongs are fossils and current life. And those things are obviously related. Look, there's a handle on the fork. They're obviously related, but if we can come at a problem that has a specific problem within changes in life, and these two pieces of evidence align to show us the same thing, that same thing is likely true. Can we prove that it's true? No, we don't ever prove anything in science, but we can say that it's likely true if these two both point for the same thing. For instance, if I have, okay, let's take the example of a fairly recent occurrence, but let's take the example, and I have a nice little solution at the end of it. Let's take the example of dinosaurs having feathers. I have here my, I think this is a Velociraptor, maybe a Utah Raptor magnet. Focus. There it is. You see it has feathers. The current understanding of dinosaurs is that at least the ones late in the Cretaceous had feathers. This one's an old picture, and this one, no feathers. That's what looks like a Tyrannosaurus Rex probably, or it's meant to be a Tyrannosaurus Rex, but no feathers. When I was a kid, all the dinosaurs looked like kind of like slick lizards, big lizards. In fact, dinosaur means terrible or giant lizard. But let's think about the problem of changes in life. The specific problem here is, did dinosaurs have feathers? Well, we come about this in two directions. Current life. What current life has feathers? This is our example here. Bird. Good. Birds. The order of vertebrates called aves is their class name. And those organisms have feathers. What purpose do those feathers serve? What purpose do the feathers of birds serve?
Warm.
Yeah. Okay, you might have said flight first. Many birds do use their feathers for flight, but you'll recognize that even the flightless birds, penguins, ostriches, do have feathers. I'm going to put temperature regulation. Do they use them to fly? Sure. We'll put locomotion. What other biological purpose do feathers serve?
What'd you say?
What other biological purpose do feathers serve? What other point is there to feathers? Why else would a bird have a feather?
To warm up the eggs.
Yeah, temperature regulation. We'll keep that. We can put nesting. They do use feathers in their nests. Sure. Do you think dinosaurs have nests, BT Dub? Yeah. We have direct evidence, fossil evidence.
For mating?
Yes, that's what I'm getting at. We'll put reproduction. They're not used as such in the actual act of copulation, but they are used to attract mates, right? That's why many birds are so pretty, is that the males are colored in order to better attract a mate. Things like peacocks or parrots, the males of those species are colored so they better attract a mate. So they're used for reproduction. Now, are all of these things something that a dinosaur might want to do?
Yep.
And when I say want to, remember, evolution is not one organism's like, man, I wish I had feathers, I would be so much better, so it just like pops out feathers. That's not how it works. It's a long process that involves environmental selection. And it's not really about the individual. But all of these things are benefits that the feathers provide the bird. Now, would it make sense for a dinosaur to have these from this standpoint? Yeah, of course. In fact, other evidence, body size that we see in the fossils, something like the blood vessels within the very good fossils that we have themselves, tell us that the dinosaurs were endothermic, meaning that they could regulate their own temperature. And so this would be very useful to dinosaurs. Some of the dinosaurs, we know things like Archaeopteryx, one of the late Cretaceous, not quite a dinosaur, but that could fly. We know that dinosaurs had nests, and we know that they reproduce. How do we know that? We've never seen dinosaurs.
Because there's not fossils of eggs.
Yeah, we have fossilized eggs. We infer that they must have sexually reproduced because we can see their generative structures on the fossils. But yeah, so all those things come together with the fossil evidence I've been talking about to tell us that these dinosaurs probably had fossils. These dinosaurs probably had feathers. Now, there's also direct fossil evidence. I have seen it with my own eyes that there are imprints of feather imprints around dinosaur fossils. And when we see like a mold of a feather sitting there next to a dinosaur fossil. Now, would it be possible for those feathers from some other critter to have just been sitting there? Maybe. Like if you were very skeptical, you might say, no, those feathers were some other thing, and that somehow the dinosaur went on lunch. That's its lunch. Yeah, it's an owl. Good. Great suggestions. But in 2017, I believe, there was, you know how sometimes insects can be preserved in amber? There was a fossil found of a dinosaur that its back half was preserved in amber, and that had feathers. So now there's direct evidence. We as much as we know anything about dinosaurs, we know that at least the ones late in the Cretaceous had feathers. So that specific problem in the changes of life, why does that change in life? Were there always dinosaurs? No. Did dinosaurs and their ancestors always have feathers? No. So that represents a change in life. What's the general term for change in life on planet Earth? What do we call it? We call it evolution, and we don't want to get tripped up in the the consternation, the arguments that people have around us. Because when we say, or when I say evolution, I specifically mean the changes that have taken place in life, on the grand scale, the changes that have taken place in organisms generally. I don't mean adaptation within a single organism. Remember we talked about how one creature, like Tiktaalik in that video, doesn't just decide to go on land and then now it is a new creature. That's not how evolution works. It takes a long period of time. Yeah, that's the one. That Mason has found the picture of the dinosaur that was preserved in amber, and you can see there.
Feather and there's a little ant right there.
Feather. And there's a little ant with it too. Okay, let me grab me that. I'm going to show it to the camera so that the YouTube viewers can see what we're talking about. Copyright, whatever. Just look at the. Oh no, what did I do? Anyway, this is all pictures of it. Nice. What would you type in this so the people can find something? Fossil found in amber and feathers. Yeah. So if you yourself go to Google and type in fossil found in feathers and amber, or in amber and feathers, you too can see the fossil to which I was referring. But when I talk about evolution, I mean the changes. We sometimes say it this way: a change in allelic frequency over time. And we'll go more in depth with that. There's a section, a lesson, I think in the next unit about how genes work with evolution. And there's actually the whole next unit is titled evolution. But when I say allelic frequency, change in allelic frequency, alleles are expressed genes. And frequency means how often or in what way those are expressed. And over time means that, and really, you don't have to look far to find that life and time itself cause change, right? That tree is taller now than when I first started working here. Mm-hmm. Yeah, it is. The buttes, technically, probably on average, shorter now than when I started working here. You've been that short the whole time. You all, when I started here in 2015, how old were you?
We're shorter.
5.
You were 5. You were in kindergarten.
7.
You were shorter then. We know it's not. No one is arguing that change doesn't occur. The argument occurs into what is the scale of that change. How can life change over time? Specifically, the argument usually comes down to how can one organism change into another? And remember, we talked about that's related to a misconception that people often have about evolution, where it isn't this. It isn't. What would you use your example of your lab? Snails?
Snail.
It isn't
Gary.
speed. It doesn't. This snail
Gary.
notices a change in its environment. It wants to go faster, and so it changes into.
Turbo.
Is that just got flames on it? This is supposed to be flames. And it's got a helmet on, so it can stay
You
safe.
can put movement things.
Oh yeah. It isn't that this thing notices about its environment. It doesn't even have to be conscious, or it can't be conscious. But it isn't that this thing notices about. Oh, I need to draw its little eyes. Oh, that was kind of sad. It isn't this thing notices its environment. It's not as good at its environment as it wants to be, and so it decides to change, or it even has children that are different. Right? It's not this chain where now this one's like, I wish I was a little bit taller. I wish I was a baller, it says, and so it gets the 6'4" Impala. Right? It isn't that it's a chain of things changing over time. It's a branching tree over time. There's a very famous it's thought to be Darwin's the genesis of his ideas. He has this thing where there's like this little chart in his note that's pretty roughly sketched, kind of like this, and it just says the words "I think" over it, and then ... And it's explaining this that the structure of life is branching. That this thing, if we say this is people, it's not that people and come from chimpanzees. It's that people and chimpanzees share a common ancestor, which seems fairly plain if you look at their structure just compared to like a fish. Like if this up here is a fish, right? It seems like, at least the chimpanzee has fingers like I do, not the fish. But anyway, we're getting a little bit too deep into evolution because we are going to talk about that again in the future. I just wanted to explain to you that the consternation that people have about this is a lot of times based on kickback to the idea that one thing evolved from another thing, but that is not what we usually, that's not the way it actually works anyway. Let's look at this. So we have these two pieces of evidence that can tell us about the way life was in the past. Fossils that provide evidence for the way organisms were then, and organisms now that can provide evidence for the way their ancestors might have been. Another example of this is that I have, let's look at these things. This is going to be really good drawing, so just hold tight.
Foot.
Nope.
Boot.
Santa hat.
No, stop. Stop guessing because you're going to hurt my feelings.
A sock?
No.
It's cramped stocking.
I see tree.
Come on, guys. What is this? You should know, at least from like history.
Fishing.
Music notes.
No.
Piano.
You
Type
said-
it.
No, you can get a little
Typewriter.
closer. Yeah. What? Say it again.
Typewriter.
Yeah. Okay. Good.
Ice.
That's a Chromebook.
Mac.
Yep.
That was
And it's got
6K.
someone watching YouTube on it, and what are they watching? Probably a cat.
It's a dog.
That is a dog.
cat.
Okay, so the example is, let me make this a little bit more 3D. Ooh, yeah, that's looking really slick now. Got a little bit of a wonky screen, but did this, are these two things the same? Obviously not. Obviously not. This is like, maybe we might even say this is a past version of this, but do you think the technology of the typewriter led to other things besides just the laptop?
No.
Probably.
Probably. It wasn't just a chain, right? It didn't just, and, furthermore, and this is a common argument people use against evolution, but there are still typewriters. So if all the typewriters turns into laptops, you see the correlation there.
Yeah.
Like someone says, but there are still monkeys, so if all the monkeys evolved into people, how come there are still monkeys? This is the same thing. Of course, there are still typewriters, because the typewriter didn't become a laptop. The typewriter led to the development, and it also led to the development, let's say, of a keyboard.
PC.
And a printer.
And
Oh,
a cashier.
And a, maybe, Cameron, maybe a cash register of some kind. But this one thing, this one technology, and remember we learned at this at the beginning of the year, the technology is iterative, and in some ways, life is iterative. That this one thing leads to a different branching effect of things. Excuse me. So what evidence is there of the earliest life? Are there fossils of the earliest life?
No.
No.
What do we think must have been the earliest life, and how do we know?
One cell.
Yes, single-celled organisms. Probably didn't even
Start with the
have.
base.
I'm drawing cilia on it, but it probably didn't even have cilia. Probably the most basic kind of life was just a phospholipid layer, maybe not even phospholipid, but a lipid bilayer. That is two bubbles of oil, a bubble of oil with a bubble of water, and inside of here is just genetic material, made of nucleic acids, maybe made of some proteins. Probably RNA made of amino acid chains and nucleotides.
Boba.
Boba.
Okay. And what evidence might there be for this thing? Well, for one thing, your book really interestingly points out that the kind of carbon that is used by life, we sometimes even call life carbon-based life form, but this kind of carbon that is used by life is already present in the rocks of Earth 3.8 billion years ago. The rocks that we have dated 3.8 billion years ago, 3.8 giga on them, 3.8 giga on them, the rocks contain carbon associated with life. That we already see some maybe an inference of life. We wouldn't say for sure that the life developed at this time, but that ratio of carbon in those early rocks tells us that life may have, that we can infer that it may have existed at that time. We also have evidence, some very hardy fossils of stromatolites. We learned about stromatolites in the video. Stromatolites. Remember those, they look kind of like mushroom-shaped structure, but what are they made of?
They're made of little guys.
Little guys, yeah, I'm drawing them in green for a reason. Are they plants?
They're algae.
They're like algae. They're like algae. They are cyanobacteria. Cyanobacteria. Bacteria. And these guys can do what? What can these little guys do?
Photosynthesize.
Photosynthesize.
Produce oxygen.
And remember, we associate these with the great oxygenation event. The byproduct of photosynthesis is oxygen. And we see again in the rock record that around 2.5 or maybe 2.8? 3.5. No.
Are there still stromatolites?
There are still stromatolites. That's actually,
Yeah, there is. There's so much sharp.
I wish it would tell me the date of the earliest stromatolites.
17.
Oh, 3.5 gig on him. That was right there. 3.5 gig on. So we see 3.8 gig on him. That there is. This is 300 million years before this. That there is this carbon type of carbon ratio associated with life. But 3.5 gig on, we have now fossil evidence, direct evidence of cyanobacteria, and the cyanobacteria and stromatolites still exist. So that's current. So you see again this two-pronged approach. We have fossilized stromatolites from way back then, and we see current stromatolites. So those two prongs come together and say that this kind of life probably existed back then. And that it can photosynthesize. Current stromatolites photosynthesize. And around this time, we start to see the other rocks on planet Earth reflect, remember like the banded iron formations, reflect an increasing amount of oxygen in the atmosphere. So the question is, does life change over time?
Yeah.
Yes.
Yeah, we think it does because the evidence suggests that. The evidence suggests that. Can we prove that life changes over time? Not really, because can you prove that you're even the same person that you were yesterday? I mean, can you prove that you're not just a flash of consciousness and all of this is a dream in like a random electron cloud in some galaxy somewhere and you're just like made all this up? No one can prove that. So there's no proof that this is true. But the evidence all suggests, in so much as we have evidence of anything, that life changes. That the nature of the whole universe has changed, and that also applies to life. Your book also talks for quite a while about extinction.
Yeah.
Extinction. What's the idea of extinction? What does that word mean?
It means all the animals of the species are dead.
Erratic.
Only animals?
All thingies, organisms,
All members of
a
a
species
species
are
die.
eradicated.
Die. What about mass extinction?
Lots of different species are extincted.
Yeah, many extinctions. We use mass extinction events to kind of break up the geologic time. So you remember, let me see if I still have one, otherwise I'll use your stream. You remember this?
Yeah.
So the breaks that we have, now you'll notice, they look pretty even at first glance, but you'll see they're not every, like, it's not like every 100 million years we have a new thing named. You see that a little bit better on my slightly more in-depth one that I have right here. That they're not all, it's not like every 100 million years we start a new period or era or whatever. They're pretty uneven. And the reason they're uneven is because they're based on, usually, not all of them, but usually these divisions between, for instance, like the Permian and the Triassic are based on mass extinction events, things that we have evidence for. What evidence would there be for a mass extinction?
Lots of fossils in a certain rock layer.
Okay, so lots of fossils in a certain rock layer, and then above that, none of those kinds of fossils. So we can say that everywhere in the world we see rocks, for instance, that are 250 million years old and older. We see all these trilobites. And nowhere in the world do we find any rock layer that is younger than that where there are any trilobites at all. And so we say all the trilobites went extinct 250 million years ago in the Permian-Triassic extinction event, which is still yet to come in our video. But we use, basically, the point of this whole lesson is that we use the fossil record and we use our experiences on planet Earth today to infer the changes that life has undergone as Earth has gone older.
Yes.
It's like puberty. That there's always, the changes occur, and you can't stop it. It's kind of like Earth is going through that with the life. The infection that Earth has, called life, continually changes over the face thereof.
Why are we in infection?
Yeah.
Why are we in
Because wouldn't it be nice if we just had a beautiful, irradiated, scoured rock with no life on it like all the other planets in the solar
Are you
system?
an alien